Hello and welcome. This video will teach you about the Euclidean algorithm, which is a set of steps we can follow to find the GCD of two positive integers. Before we get into the algorithm itself, let's look at what a GCD actually is. GCD means greatest common divisor, which is the largest positive integer that can evenly divide a set of integers. To evenly divide means to leave no remainder when dividing those numbers. For example, the GCD of 6 and 4 is 2 because 2 is the largest positive integer that can divide both 6 and 4 without leaving any remainder. In this case, the GCD was easy to spot since both the numbers are quite small. However, when the numbers in question are quite large, it becomes very difficult to directly spot the GCD. That is why we need an algorithm capable of helping us find the GCD. So what is the Euclidean algorithm? It consists of two steps, or two rules, which can be repeatedly applied to break down a sum and help us find an answer. The first rule states two things. Firstly, it states that the GCD of a, which is a positive integer, and 0 is equal to the GCD of 0 and the positive integer a. What this means is that the order we say or write the numbers in doesn't really matter. Just as the GCD of 6 and 4 is 2, the GCD of 4 and 6 is also 2. It also states that the GCD of 0 and any positive integer is always equal to the positive integer itself. This is because any positive integer can evenly divide 0. Any value of a times 0 will always return 0 and will leave no remainder. And the greatest positive integer that can evenly divide a is itself a. Therefore, the GCD of a and 0, or 0 and a, will always be a. The second rule states that the GCD of two positive integers, a and b, is equal to the GCD of b and r, where r is the remainder we can find when a is divided by b. We'll get into the proof of the second rule a little later, but first let's understand how this rule works by applying them to a sum. Say we need to find the GCD of 192 and 78. We can here use the second rule. We know our a is 192 and our b is 78. To find our remainder r, we need to do long division, and when we do that, we find that the remainder is 36. When 192 is divided by 78, it will leave a remainder of 36. Since the GCD of a and b is equal to the GCD of b and r, the GCD of 192 and 78 is equal to the GCD of 78 and 36. Now we can apply the second rule again. When 78 is divided by 36, it leaves a remainder of 6. In this case, our a is 78, b is 36, and remainder r is 6. So the GCD of a and b, which is 78 and 36, is equal to the GCD of b and r, which is the GCD of 36 and 6. Once again, we can find the remainder. When 36 is divided by 6, it leaves a remainder of 0. Our b is 6 and r is 0. So the GCD of 36 and 6 is equal to the GCD of 6 and 0. And now remember the first rule. The GCD of a and 0 is always equal to a. So the GCD of 6 and 0 will always be equal to 6. Using the algorithm, we were able to continuously divide or break down the bigger sum into smaller sums until we could arrive at an answer. That is it for part 1 on the Euclidean algorithm. Thank you for watching part 1. In part 2, I'm going to prove that the GCD of a and b is equal to the GCD of b and r. So make sure to stick around and watch part 2. Thank you.